Okay, very good evening, children. Today I'll be starting with next topic after logic, that is LPP. Now, what exactly is LPP? We'll see in the later half of the chapter. First, let us learn some basic inequalities. Start with the first one. I'm talking about x greater than equal to 0, means x is always positive. So if I want to shade a region where x is greater than equal to 0, it means I'll shade this region. I'll show you with the pen. So this will be my region where x is positive, this entire region, and where x can be 0 also. So this is my region where the inequality x greater than equal to 0 holds. Okay. Next, what about y greater than 0? Y greater than equal to 0? It means everything above this axis, this one, this blue color region is called as y greater than equal to 0. Okay. Now I want x greater than equal to 0 as well as y greater than equal to 0, means both should be positive or both can be 0. So I'll only shade the first quadrant. This quadrant will be my interested area. I hope you are getting it. This will be my region where x will be positive and greater than 0 and where y will be positive and greater than 0. Let's move on to now particular things. Now I want to shade a region where 2x plus 3y should be less than equal to 6. Also x and y both positive. So in our LPP, this is the very good thing. We will restrict our Cartesian plane only to first quadrant, because always x and y is taken to be 0 or positive. So I'll only talk about the first quadrant. Let's see how to draw the graph or region for 2x plus 3y less than equal to 6. So first I'll convert this assuming that there is a equal to sign. So first I have taken 2x plus 3y is equal to 6. I'll convert this equation into double intercept form to make it easy to draw the line. So I'll divide everything by 6. So I get 2 3s are 6, that is x by 3 plus y by 2 equals 1. So what will be a point on x-axis? 3, 0. Point on y-axis 0, 2. This is 3, 0 and 0, 2. So I'll mark 3, 0 on x-axis, 0, 2 on y-axis, and I'll join the line. This is how I'll get the graph. This will be my straight line now. 2x plus 3y equals 6. If I talk about 2x plus 3y equals 6, this will be my line. Now I want answer to be less than, means this value should be less than equal to 6. So when I talk about less than, it means towards origin. So this line has two regions. One, this is away from origin, and this inside part, it's towards from origin. So if I talk about greater than 0, greater than equal to 0 for x and y and this region, then my shaded region should be only this much. This will be my shaded region, okay, for this particular scenario. When I talk about less than, means towards origin. If I talk about more than, it will be away from the origin. Okay, let's move on to one more example. Okay, here I have taken x plus y greater than equal to 4. Again, first I'll convert into double intercept form. So I'll get x-axis as point on x-axis as 4, 0, point on y-axis as 0, 4. So with these 2 points, I can draw a line x plus y equals 4. You can see I have drawn x plus y equals 4. Now I want to shade the region x plus y greater than equal to 4, and by default x, y is greater than equal to 0. So I want x plus y should be more than or equal to 4. So I will go, it is more than, so I will go away from origin. This part is towards origin, so I will go away from origin. So I need to shade this region. Here it has been showed the negative quadrants also, so don't consider them. This will be my region of x plus y greater than equal to 4. Okay. Next, now I want 2x plus y greater than equal to 3 and x plus 2y greater than equal to 6 and xy greater than equal to 0. So first I'll convert these both into double intercept form. I'll locate their points, I'll draw these lines. So see, always prefer drawing a table. This table carries 1 mark in your exam. You will show double intercept form. You will show points on x-axis and y-axis, and accordingly you will draw lines. So see, this is my first line. This is my second line. The intercept, see, it is 1.5. It is not compulsory to draw exact. You can draw rough sketch also. So 1.5 and 3. Then for second line it will be 6 and 3. Now I want 2x plus y should be greater than equal to 3. Means I should go away from origin. So my origin should be this side. Then if I talk about x plus 2y again greater than equal to 6. So again I should go for region which is this side. So I want a region which is satisfied by both. So the region which is satisfied by both is shown by these black lines. This will be my interested region where my both the conditions will be satisfied, that even this will be greater and also this will be greater. So I only shade this region. I will not shade these dotted lines also. I will just shade this region. You can just draw the red lines the way I have drawn. No need to draw that many number of lines. Okay. Now let's start exactly what is LPP. Now suppose you are planning to open a shop where you're thinking of buying computers and desktop and laptops. But the problem with you is you have certain limitations. You don't have a huge amount of budget with you. Also, you don't have a storage space where you can store ample number of desktops and laptops. So you have to think about all those considerations and you have to plan how many compute desktops or laptops you should buy so that you can achieve maximum profit, or you can buy them at a minimum cost. So when you open a shop, we have certain objectives that our market purchase should be at a low cost and my selling should be at high profit. So achieving the goal is called as objective function, and to achieve that we are having certain problems. That problems are called as constraints. So see, LPP means linear programming problem. This is what I've said. We are planning to buy X laptops and Y desktops. Now the main problem with me is I only have a budget of 60 lakh rupees and I've got a quotation that I'll get a laptop at 40,000, I'll get one desktop at 50,000. So since my budget is 60 lakhs, I can say that I can buy X laptops and Y desktops such that 40,000 X plus 50,000 Y should be less than equal to 60 lakhs. I hope you all are getting it. My second constraint is I only have space to store 75 desktops or laptops altogether. So what I can see that X plus Y, that is number of laptops plus number of desktops space, can be less than equal to 75. That is, I can buy computers, desktops and laptops together up to 75. I cannot go beyond that. So what I have done to achieve my maximize profit or to minimize cost, I had certain limitations, which limitations are called as constraints. Now with the help of these constraints, I have to achieve my target. So what I have done, I had a problem. I have programmed that problem in linear equations. So programming a problem in linear fashion is called as LPP. Okay. Let's see exactly what is the definition of LPP. So LPP is linear programming problem is one that is concerned with finding the optimal value, that is either maximum profit or minimum cost of a linear function, that is z, which is denoted by objective function of several variables like x and y. We will limit to 2 dimensions only, so we will have always 2 variables x and y subject to conditions. Those conditions are called as constraints, that the variable are non-negative. Since starting I have said that x and y will always be positive and greater than equal to 0. So that means they will be non-negative. So I have taken one example. maximize z equal to 250x plus 75y subject to constraints. So I want to buy something x products and something y products such that my z should be maximized. So if I'm talking about maximize, it is always profit by considering all these constraints, or you can say problems or conditions which I have. So see, I have two linear equations. So first I'll convert them into equality and I'll draw the straight lines for them. So what I'm doing, I'm maximizing z equal to 4x plus y subject to the constraints x plus y less than or equal to 50. Sorry, here the equation is missing. It will be seen down. So let's see. So first what will I do? I'll draw the table. It's very important to draw the table. This table carries 1 mark in your board exam. So for x plus y equal to 50, my double intercept form will be x upon 50 plus y upon 50 equals 1. That is point on x-axis 50, 0, point on y-axis 0, 50. Similarly, second equation is 3x plus y less than or equal to 90. I'll assume it to be equal. So I'll get x upon 30 plus y upon 90 equal to 1. So my coordinates on x-axis become 30, 0 and y-axis becomes 0, 90. First we'll draw these two straight lines. I have drawn these two lines. This is the first line 0, 50 and 50, 0 and 0, 50, then 30, 0 and 0, 90. Now see, I want less than. So as discussed last time, I had said less than means towards origin. So if I talk about this is towards origin for the first line. Also for second line, this is towards origin. So I want a region which is satisfied by both, means both the conditions are satisfied. So first line says that my region should be this triangle. Second says that my region should be this one. So I'll shade the common region. So my feasible region means my team members are giving me saying that these are the solutions you can have for x and y. These many solutions you can have for x and y. So what will I do? I'll draw a polygon covering the region. This is my interested area of region. Now I mark label the points on the corners only. But that is the only thing which will give me the answer. So how many solutions I have now? A, B, C, and this is D. Out of this, I know three coordinates by default. A is 0, 0, B 30, 0, D 0, 50. Problem is with C. I'll find C always by simultaneous solving of the equations of the lines intersected. So C is the intersection of these two lines, that is this line and this line. I'll solve these two lines simultaneously to get the coordinates of C. Don't get graphically because you will get rounded up values which may make the answer wrong. Solve this equation simultaneously, get the values of C and D. It is good if you get the answer in fraction. Now I have only 4 points. That is, I have 4 solutions A, B, C, D. So these 4 solutions or this region is called as feasible region. Now I want to find out of these 4 solutions which will maximize my Z or which will follow my objective. See? So see, the 4 points were A, this was B, then C was 20, 30 and D was 0, 50. And what was my Z? My Z was 4x plus y. So I'll substitute the values of x and y in z function and find the values of z. So for first one, z comes out to be 0. Second one, z comes out to be 120. Third one, it comes out to 110. Fourth, 50. So I want maximize. So which value of z is maximum? This 120. So I'll say that the optimum solution will be when I buy 30 products of x and 0 product of y. This was the actual graph. This was a feasible region, blue color shaded. You have to show the region. You have to label the points also. Okay. This is the way you will solve. We'll cover more sums in the next session. This is just sample. If you don't understand, don't worry. I'll be covering many problems in the upcoming sessions so that you'll understand. Now first task is you should know how to draw these lines. This is nothing but you have studied in 10th standard how to draw linear equations. Then we'll see how to draw the region, then to find the polygon, then the coordinates, and then the value of z. Thank you.